As part of your solution process to some homework problems and project problems, you're going to be required to create a flowchart. And a flowchart is going to be a visual way to plan out how your program is going to work before you even start writing any code. So you're really able to think about the logic and the flow of the program before you're worrying about the very specific ways that you're going to be implementing it. So it's a plan before you get to the coding that can be updated as your coding begins, because it doesn't have to be necessarily perfect before you start the coding process, because it's very probable that you're going to find some flaws in the way you thought the flow was going to work or the program is going to work when you actually start to implement it. But it's kind of your first plan as you go into the coding process. And it's written in really words and concepts. There's not going to be any programming, no code in the flowchart itself. What you're going to have to do when you get to implement it is translate the ideas and concepts in the flowchart into those things in the code. And a nice thing about flowcharts is they're basically going to be agnostic to what coding language you're working in. If it's MATLAB or Python or C or whatever, almost every program language is going to be able to be written following a flowchart that you make. Now, there are some more specialized ones, or there's, if you're down to working in assembly or something very close to the metal type of programming language, then the flowchart might not make as sense. But anything you're going to be working on in this class, you can start with a flowchart. Now, there's no single way to create them. In a couple of ways, there's no universal representation of what different concepts are in the flowchart. And also, for almost any problem, there is not a unique way to solve it. The order that you do things can be different. The order in which you put if statements or the way you implement loops can be different from one version of a program to another, even though they are going to accomplish the same thing. The flowchart is giving you the plan for one way to implement the problem. And keep in mind, the flowchart does not have to be perfect before you start the coding process. But what you do want to do with it is, once you kind of complete a draft version of the flowchart, is try it with some different test cases to see logically, is your program going to make sense, at least on paper, the way you want it to? So trying with different inputs and see what the outputs are. Are they the expected outputs as you go through on paper the flowchart? And then hopefully, if you implement it the same way in the code, then the inputs you put into your code version are going to match the expected outputs. Now, honestly, flowcharts are going to be fairly limited. They're really good when you're starting off learning coding to really think about the concepts of the coding before you worry about the syntax of the coding. But once you get into problems beyond the scope of things we're going to look at in the homework, or even things we look at in the project, flowchart usage is really going to break down, because the problems start to get much too complex, much too big to fit on paper or even to really write down in a meaningful way. So when you're learning this, what we were calling computational thinking, thinking about how if statements or conditional statements work, how loops work that we're going to talk about in the next section, or how we save our data or our variables, this is a really good practice to get into to kind of separate the idea, the computational thinking part, from the syntax and the coding part. So for this class, I'm going to go through the flowchart notation or representation that we're going to be using. That seems pretty accepted in the coding community, but different groups are going to have their own version of flowchart of how they represent the different ideas, the different symbols they use. But I will use this version of it consistently for this course. And on the slides, I have it color-coded just so it's a little bit easier to read. And when I have flowcharts on slides, I'll do it that way. But when I'm drawing them out, or when you're drawing them out, just using the shape of the different processes is going to be fine. And for variable names, I'm typically going to use lowercase variable names when we have scalars or vectors, and a capital variable name when we have a matrix. Again, this is the notation for this class. It's not necessarily universal. And whenever I'm talking about a variable that's a vector, it's going to be a lowercase name followed by the tilde. Again, that's just so that in the flowchart, we know we're talking about a vector, or I'll use the word vector if there's space for it. But the tilde is going to imply that a variable is a vector. When we actually go to code it, that tilde is not going to actually be there. So let's look at the different elements that we're going to have in the flowchart. So we can have inputs and outputs. They're basically going to be at the top of our flow chart and the bottom of our flow chart. So if we have something like a function, functions almost always are going to take an input or multiple inputs. So we're going to put one of these parallelograms at the top. Those are going to represent the inputs or the variables coming into the function that we are to write. Now, also if we're working on a script, not a function, we might have some constants that we're given, the acceleration of gravity or some physical constants. Those can be represented in this block. They are given at the start of the program. We don't have to calculate them or do anything else. They just are going to be given to us somehow. And if we're working on a function, almost always we are going to end with an output. We're going to output or return a variable or several variables. So like in this example, there would be things in between the two parallelograms vertically, but we're given a list of integers at the start of our function, let's say, and then we're returning a variable named s that's the sum of those numbers. And it would be s is a scalar by this representation, x is a vector by this representation. And if we have a script file, maybe we are going to be saving some variable at the end. Maybe we're saving it to a CSV file. Maybe we're saving it to a mat file. Then we could have one of these parallelograms at the end of a script file. But again, in a function, almost always these are both going to be there, and sometimes in a script. And they're going to typically be at the very top and the very bottom of your flow. Then we have a process or a statement. So this is typically something that's like a calculation, or again, because these are representing concepts, it could be a series of calculations that's just we're putting into that block. And when we go into the code, it actually might be multiple lines of code. So it could be something about applying the free fall equation. So maybe going into this block in our flowchart, we are giving the value of gravity, we're given our initial height. And then when we calculate the free fall equation, we're going to take those variables, do the calculation, and then out from there is going to be either the velocity or the acceleration at a certain time. So these rectangles are going to be typically these calculations. And we can come to decisions. That is going to be this diamond shape, which is going to be shaded green for the purposes of the slides. So this decision is really getting to what this section is all about, the conditional statements, the if statements, or the if blocks. And we're going to represent this by really the simplest form is that when we come to a decision, whatever we're evaluating will either be true or false. It's a binary output. So either the statement is going to evaluate all the way to true or to false. Now, we were talking earlier about if, else statements, and those could have 3 or 4 or more types of outputs, but really those can be built by a sequence or a series of binary decisions, as we'll get to when we talk about some examples in the next videos. So this could be an if statement that has a true or a false with these two branches, or this could be the determination if we continue a loop that we'll talk about in the next section, a while loop or a for loop. We can again ask this question, should we go back to the top of this loop or should we move on? We're going to represent that with this decision. And for the purposes of this class, I'm going to typically stick with the true branch being coming out from the left of our decision and a false branch coming out from the right. But it is a good idea to also label it the true statement or the false statement. So what are we putting inside the decision is something that can evaluate to true or false. So in this example, we see Q is greater than 20, question mark. So if that statement is true, we're going to go through the left branch. If that statement is false, we're going to go through the right branch. But we can also have something more abstract inside that block that is going to have to be translated into code. So is a number odd or even? Is a number divisible by 5? Is a number prime? Something like that, that again can be true or false, but when we get to the actual putting it into code, we're going to have some function or some calculation that determines the truthfulness of that statement. So we're going to be putting together these different blocks to create a full flowchart and see how it works in the upcoming example videos.